All right, let's look at the second example of 7.3. So now that you've learned how to simplify expressions, we're going to now multiply expressions together, rational expressions. And this does involve simplifying because sometimes you're going to want to cross-cancel your expressions, and sometimes after you multiply, you're going to have to simplify. So you're don't forget how to simplify just because we're moving on, because you're going to need to use it with these problems. So let's go, and I'm going to show you one of the core concepts from the journal before we get started on this. Now, you already know how to multiply fractions. Just as a reminder, when you multiply two fractions together, all you're doing is multiplying across. You're multiplying the numerators together, and you're multiplying the denominators together. So when you look at this right here, all you're getting is your numerators, a and c, so you get a times c on top, and your denominators are b and d, so you're getting b and d on bottom. Now once you have this expression, you want to go ahead and simplify if possible. So if there's any common denominators or any common factors, you want to go ahead and simplify those. Now let's look at an example here. So we've got 5x squared over 2xy squared times 6xy cubed over 10y. Now, what you want to do here is just go ahead and multiply across and combine like terms. So your coefficients, 5 times 6, give you 30. X squared times x gives you x cubed. Y cubed times 1 gives you y cubed. On the bottom, 2 times 10 gives you 20. X times 1 gives you x. Y squared times y gives you y cubed. Now, what we can do is we can try to split up each of our terms to take out the common factor. This helps you visualize what we're canceling out here, so you can see exactly what's left. Now, a lot of you will get to the point where you don't have to split it up like this. You're going to be able to identify that, well, 30 over 20 is 3 over 2. X cubed over x is x squared. Y cubed over y cubed is just 1. And that's where you want to be. You want to get to that point. But when you're first working on these, if you don't have that mental math capability right now, it's totally fine. It took me a while. I had to write out a lot of my expressions and my terms, and it was very helpful. I got a lot out of it. So please, especially when you're working on a test or your homework, make sure you write out your work so you can see where your mistakes are if you make them, or you can see exactly how to do it right. So in this case, the common factor with 30 and 20 is 10. So you pull out the 10 and write down what you're left with. So 30 in the top, 3 on top, 2 on bottom. So we can cancel out a 10 from each. With our x cubed and our x is our common factor. So we pull out x on top, we're left with x squared. X on bottom, these cancel out. And our last term, y cubed, we have y cubed on both top and bottom. We just cancel those out and there's nothing we're left with. Now you go ahead and you just write all of your leftover terms together. So we're left with 3x squared over 2. Now when you look at your original functions, the value, in order to get our asymptotes, we just set our denominators to 0. And you'll see that both x and y will give us a value of 0. So we have to make sure that we write down what those restrictions are to our domain and range. Okay, so let's go back to the example problem we want to look at. So right now we've got 8x cubed times y over 2x y squared times 7x to the fourth y to the third over 4y. So we can go ahead and multiply across. Our constants give us 56, x cubed, x to the fourth, x to the seventh, y times y cubed, y to the fourth. On bottom, our constants are 2 and 4, so that's 8. X times 1 is x. Y squared times y gives us y cubed. So easy first step right there. We've got now everything simplified down to one term. Now we're going to start factoring out our common factors. So luckily, 56 is a multiple of 8, so that's 8 times 7, and we see that the 8's cancel out. X to the 7th and x, see that our common factor is a single x, so we take 1 out and we're left with x to the 6 on top, so we cancel the x's out. Y to the 4th, y cubed, that has a common factor of y cubed, so we pull that out, write our leftover of y, cancel those out. Now, you'll see that what we have here is we're left with 7, x to the 6th, and y in our numerator, and nothing in our denominator. Now, this does not mean that this is 0 or nothing. This means that we are left with 1 in our denominator. So we're going to end up with 7 x to the 6 times y over 1. And what we do, the way we write that, is just 7x to the 6 y. And again, when you look at our original function, we've got 8 times x times y cubed. The values that are going to make our denominator 0 are x equals 0 and y equals 0. So we have to write down that x cannot equal 0 and y cannot equal 0. So that's going to be our limitation. Okay? Now, what I want you to do is, for your practice problem right now on this first one, we're going to go ahead and look at extra example 2. So I want you to go ahead and find the product of this. Do the exact same thing we just did, multiply across, and start simplifying by pulling out the common factors in this one, and you will be okay. All right, for the second part, we're going to go ahead and do a second question in here because we're moving right along. We want to go ahead and look at example 3 here. Now, example 3, the only difference right now is that instead of just having monomials, so if we go back here, in example 2, we had a monomial for each fraction. Our numerators and denominators were just single terms. Here, we've got polynomials in our numerators and denominators. So again, you want to think back to how you multiplied polynomials together. But when we do this, we're gonna look at how we can simplify this so we don't have to multiply complex expressions together. We're going to see how we might be able to simplify them and do some cross-canceling before we actually do the multiplication. So let's go ahead and look at each one of these. What we want to do first is we want to take each expression and see if we can factor it down. Now, if we look at this, what we've done is we haven't done any multiplication together. We've simply taken each polynomial and we've looked to see if we can factor it. Now, let's look at each numerator and denominator one by one. We've got 3x minus 3x squared. We see that this has a GCF of 3x that we can actually pull out, and we're left with 1 minus x. Okay? What we're doing is we're trying to factor each of these. Okay? You either factor into multiple binomials or pull out a GCF that allows us to simplify. So this is really important. You need to think back to your factoring skills and really make sure that you're sharp with those. So our first turns into 3x times 1 minus x. Let's go to the denominator. We've got x squared plus 4x minus 5. We see that this turns into x plus 5, x minus 1. Our second numerator, x squared plus x minus 20, is simply x plus 5, x minus 4. And 3x we can't simplify any further. Okay, again, I'm going to reiterate, making sure you're solid with your factoring is really going to help. If you struggle a little bit with the mental math and factoring in your head, you want to make sure that you are doing the diamond method or by grouping, whatever method you're comfortable with. Now, you want to be careful because we've already gone over factoring. I'm not going to reteach it in this section. You're already expected to be comfortable with it. If not, you need to go back. I've got videos online, or go through Khan Academy or just through the book Make sure that you are solid with this. Okay, now what we can do, because we've gone and factored these down, we know we can just multiply across. Now, we don't want to combine any terms right now. When we multiply across, we're just going to leave this with all of our factors still not combined. What we're doing right here is we want to go through and we want to start looking for common factors that we can cross out before we start actually combining this. So what we're going to look at is we want to see which ones we can cancel. Now, we've got 3x and 3x. We know we can cancel that out. X plus 5, we know we can cancel those out. X minus 4, we're not going to be able to cancel that. There's nothing else that is going to, cancel. Now, we've got 1 minus x on top and x minus 1 on bottom. Now, this is where you want to be able to recognize this and see that these are almost identical factors. Not quite, but almost. This is where you need to remember that you have some tricks to rearrange factors. Now, what we can do with x minus 1 right here and 1 minus x, if we actually take our 1 minus x, we can rewrite that as negative 1 times x minus 1. So if you look at this right here, we've got 1 minus x. If we take this and let's factor out a negative 1. If we take 1 divided by negative 1, so let's factor out the negative 1, that's going to give us negative 1. So again, if we factor a negative 1 out of 1, that gives us negative 1. If we take a negative 1 out of negative x, that's going to give us plus x. And what we can do right here is negative 1 plus x, if we just switch these two terms, that gives us x minus 1. And all we're left with is a negative 1 in front. So you'll see that these two terms right here are identical. 1 minus x and negative 1 times x minus 1 are the same terms. So we didn't change anything. We're just, through factoring, we're just rewriting this. So again, if you are not quite sure on this, make sure you ask me in class or come back and rewatch this. Okay, now that we have rewritten this, you're going to see that we've got quite a few things we can cancel. So we've got 3x and 3x, x minus 1 and x minus 1, x plus 5 and x plus 5. So all we're left with is negative 1 times x minus 4. And what we get is when we do that, we get negative 1 times x minus 4, distribute, that gives us negative x plus 4. Now, what we need to remember is if we look back here at our original function, we've got x cannot be equal to 1, negative 5, or 0. So you have to make sure that you write down your exclusions. So x equals negative 5 because of right here. X plus 5 can't equal 0. X can't equal 1 because of right here. X minus 1 would be 0. And x can't equal 0 because 3 times 0 would give us 0. So that's another exclusion that we have to make right there. So remember, after you combine all your like terms, make sure that you rearrange anything if you have very similar terms that are almost identical. If they're opposites, you can always factor out a negative 1. Once you cancel everything, you combine your last few terms, and you're left with your final answer. Okay, so I know those were two detailed examples, but you're going to be really solid with this after practicing. Now, the example I want you to do right now is I want you to look at this extra example 3 right now. So find the product of these two rational expressions. So go ahead and write it, and I also want you to write out what exclusions you have. So x cannot equal what? So I want you to go ahead and factor, combine, cancel, and then write your final answer with any exclusions. So you're going to put all of that in the text box here. Okay, good work on this one.